Today, I'd like to talk to you about one of my favorite exhibits here at the museum, gumdrop. Gumdrop is the call sign given to the Apollo 9 capsule by its crew. The reason why it was called gumdrop is when the astronauts first saw it, it still had its blue wrapping on it from the manufacturer, North American Aviation, and it looked like a big candy gumdrop. The lunar lander that also came with Apollo 9 was called Spider, because the first time they saw it, it was on a crane going across the assembly room floor with the legs extended, looked like a spider on the web. So Apollo 9, even though it didn't go to the moon, is one of the most important Apollo missions of the whole Apollo program, because Apollo 9 was the all-up test flight for everything needed to get us to the moon. So Apollo 9 flew in March of 1968. It spent 10 days in Earth orbit. During that 10 days, they did a whole series of first evers in space exploration. So for the very first time, we launched the complete Saturn V rocket, including a fully functional and man-rated lunar lander for the first time into orbit. Once they have achieved orbit, for the first time, they undocked the service module and the command module from the third stage of the Saturn V rocket, turned around in space while going 17,500 miles an hour, docked with the lunar lander that is attached to the third stage, and pulled it away for the very first time. So they did a series of flights with the two conjoined spacecraft, proving that they could fly the two spacecraft together using not only the rocket engines from the command service module, but the rocket engines on the lunar lander. And this would become very important for the Apollo 13 crew. For the first time, we transitioned astronauts from one spacecraft to the other. The lunar lander was up here. For the very first time, we did a two-man spacewalk. Now, every moment of every activity in spaceflight is very highly choreographed. And during this time period, Rusty Schweickart and Dave Scott were going to be doing a two-man spacewalk. Rusty Schweickart was in the lunar lander wearing the lunar suit, which is a self-contained suit for walking around on the moon. Dave Scott, who's the command module pilot, was going to be outside of the command module taking pictures of Schweickart being outside of the lunar module in the lunar suit. During that time frame, Dave Scott's camera malfunctioned. And for 3 or 4 minutes, Schweickart had nothing better to do than to sit on the porch of the lunar lander and watch the world go by. And you can see here a picture that he took of Dave Scott while he was just sitting there watching the world go by. So we're around the backside of the Apollo 9 capsule now. And I'm always asked, how did it come back to Earth and not burn up? So Apollo 9 stayed in Earth orbit. So when it re-entered, it came in at a leisurely 17,500 miles an hour. The Apollo spacecraft that came back from the moon came in at 25,000 miles an hour. So how do you protect your spacecraft from that kind of heating? And what causes the heating? On the Apollo spacecraft, you'll notice, and it's kind of hard to see on the video, but there are over 330,000 stainless steel honeycomb cells all around the spacecraft and on the heat shield. On the front side, which is the cold side, 2,000 degrees. Those are only about half of an inch. On the backside and on the heat shield, where it really got hot, 5,000 degrees, they're up to about 3 inches deep. The same 12 ladies are the ones who are responsible for filling all 330,000 cells on each Apollo spacecraft. And they had to be absolutely 100% perfect. After they got 1 square foot done, they would x-ray it, and if there was any flaws, you see the circles right here is where they would drill it out, re-inject a polymer resin in there to make it absolutely perfect. Now, how this polymer resin worked is as it would start to heat up, it would form a graphite layer on the outer edge of that honeycomb cell. Graphite is an excellent insulator. But as it would meet its maximum temperature, it would burn off or ablate. This is called an ablative heat shield. As it burned off, it exposed the next cooler layer of the heat shield, then to heat back up and recycle heating, cooling. And that is how the Apollo capsules got back from space. And during the whole reentry process, one of the highest temperatures ever recorded inside the command module was a little over 80 degrees. Not too bad.